Welcome to The Explainer. Today, we are tackling what is arguably the single most critical challenge facing modern businesses right now, and that is trusting autonomous enterprise AI systems. As AI agents get more advanced, they aren't just simple chatbots anymore. They're these highly dynamic entities. They make real-time decisions, they orchestrate complex workflows, and they are touching highly sensitive enterprise data. But here's the massive elephant in the room. As these systems get more and more autonomous, organizations are literally losing visibility into what data actually influenced a specific outcome. Think about it. If you can't track it, you absolutely can't trust it. And if you can't trust it, well, there is no way you can use it in a real enterprise environment. So today, we're looking at a truly fascinating solution to this exact problem detailed by Salesforce Engineering. It's called the Agent Fabric Context Catalog.
Okay, let's dive right into this. Here is our roadmap for today. We're going to start with the AI governance gap, then explore the lineage problem and see exactly how to build deterministic lineage. After that, we'll reconstruct execution paths, look at how to integrate human review, and finally, shift our focus toward continuous runtime governance.
Section 1. The AI governance gap. This is exactly where traditional oversight starts to fracture. I want to anchor our entire explainer on this incredibly powerful quote from the source material. The challenge in enterprise AI is no longer building agents quickly. It is building agents that organizations can trust. That literally hits the nail on the head, right? It sets the stakes perfectly. Speed is no longer the bottleneck in AI development. Trust is the bottleneck. Because any single layer of an AI system that is left in the dark instantly becomes a massive blind spot. And eventually, that blind spot is going to surface as a hallucination, a data leak, or a massive compliance failure. Trust, not just raw speed, is absolutely the ultimate goal here.
Now, there's a stark contrast between traditional data governance and how AI actually operates today. Think about how we used to do things. We built platforms around deterministic pipelines, right? Scheduled ETL jobs, incredibly stable, rigid architectures. It was entirely predictable. But modern agentic systems, they behave completely differently. They are out there invoking APIs dynamically, they're shifting execution paths continuously based on user prompts, the specific context they retrieve, and their own internal orchestration logic. It's like a giant, ever-changing puzzle. And the result of all that? A massive and rapidly growing governance gap between enterprise AI execution and enterprise observability.
Moving on to Section 2. The lineage problem, or essentially, why we are failing to track these dynamic agents.
So the single hardest problem in this whole space is constructing accurate lineage between an API and the specific data set it's accessing. Because these agents are literally building their execution paths on the fly at runtime, traditional governance tools just kind of guess. They rely on what we call inferred linkage. They try to infer the relationship through fuzzy name matching or, semantic clues, which gives you mappings that might look plausible, but they are absolutely not auditable. I mean, imagine handing an auditor a semantic guess during a massive compliance review. Yeah, no way. That is not going to end well for anybody. What you actually need is deterministic linkage, where those data bindings are directly observed and concretely declared right at execution time.
That brings us to Section 3, Building Deterministic Lineage. Let's look at the architecture that bridges this huge visibility gap.
To actually tackle this problem, Salesforce is integrating its agent fabric with Informatica's Enterprise Cloud Data Governance and Catalog, or CDGC for short. And together, they form the Agent Fabric Context Catalog. So what is this? Well, it's essentially a unified governance control plane. It perfectly combines Agent Fabric's API visibility with Informatica's really deep data governance capabilities. This produces a single, unified operational layer. So now lineage, explainability, and policy enforcement all live together in one place, rather than being scattered across a dozen completely different tools.
So how do we actually build this end-to-end AI lineage? Let's break it down anatomically. Step 1, it starts with the agents, which are cataloged by Agent Fabric. These agents then invoke an MCP server. That's Step 2. The request then moves to Step 3, MuleSoft APIs, and these APIs expose strong runtime configurations that declare exactly which data sources they are binding to. Finally, Step 4, it hits the datasets managed by Informatica. And Informatica contributes the metadata, the sensitive field tags, the data quality scores, the whole shebang. When you join all this together on shared identifiers, you create a complete deterministic lineage graph. You can see everything from the agent's initial execution straight down to the managed enterprise data source.
Let's jump to Section 4, Reconstructing Execution Paths. This is how we trace the agent's actual journey through this new stack.
Now, lineage is great because it tells you what an agent could touch.
But tracing? Tracing tells you what it actually did on a very specific call. So let's narrate a hypothetical journey here. Say an agent broker workflow kicks off. It invokes an MCP server, it calls the MuleSoft API, and then it queries a Snowflake dataset that's cataloged inside Informatica. As this specific request traverses the workflow, the MuleSoft Omni Gateway literally injects trace identifiers into those downstream transactions. It's kind of like leaving digital breadcrumbs. And those breadcrumbs let you completely reconstruct the exact execution path across platforms that would otherwise be totally disconnected.
And once that path is reconstructible, wow, a whole new world of operational capabilities opens up. You can immediately identify exactly which datasets influenced a specific agent response. You can surface governance and data quality signals before a response ever even reaches a user. You can quarantine sensitive agents, you can apply runtime policies selectively, and most importantly, you can contain the blast radius of an AI hallucination or policy drift event instantly, instead of, discovering it in some audit weeks later. This fundamentally flips governance from being this annoying post-development chore into a strict, absolute precondition for development. It's a real game changer.
Moving right along to Section 5, Confidence and Human Review, because we absolutely have to handle the reality of the real world here.
Okay, the reality of the real world is that external APIs, third-party MCP servers, and agents operating outside that MuleSoft layer, well, they won't always expose perfect runtime metadata. We know that. So instead of hiding behind complex black box statistics, this platform does something brilliant. It surfaces its confidence explicitly. Let's say a relationship derived directly from MuleSoft is labeled as deterministic. That might be, say, 60% of your lineage. But if an edge is inferred from semantic similarity, it is categorized separately, right there, with a specific confidence score, alongside maybe 15% of human-verified corrections. This preserves immense credibility. If an auditor starts asking tough questions, the system doesn't pretend to have certainty that it lacks. It explicitly separates what it observed deterministically from what it merely inferred.
And you might be wondering, what happens when those inferred confidence scores fall below an acceptable threshold? Well, the system routes that mapping straight to a human reviewer. This human-in-the-loop process lets reviewers approve, reject, or completely correct the inferred relationship. And the absolute best part? This validation workflow isn't just some quality gate bolted on at the very end of the process. No, it is a continuous feedback mechanism. Every approved correction feeds right back into the system to improve future inferences on similar patterns. It creates an incredibly robust, continuous audit trail that just keeps getting smarter.
Finally, we arrive at Section 6, Continuous Runtime Governance, the actual future of enterprise AI trust.
And this brilliantly illustrates the ultimate evolution required for AI systems today. Static compliance, reviewing things after development with simple point-in-time checks, that simply can't keep up anymore. It just can't. Autonomous agents are constantly evolving at runtime, especially as the models and the APIs change right underneath them. You have to move to active, continuous runtime governance. And the Agent Fabric Context Catalog enables exactly that. It allows for continuous evaluation, actively monitoring for hallucination drift, policy compliance, runtime toxicity, and any behavioral changes over time.
Which leaves us with this final, absolutely vital question. Are you relying on static compliance for dynamic AI? As autonomous AI rapidly becomes the core infrastructure of the modern enterprise, having true end-to-end governance visibility will absolutely be the layer that determines whether any of it can actually be trusted. It is time to evaluate your own systems and ensure your oversight is as dynamic as the AI you are trying to govern. Thank you so much for joining me on this explainer, and keep learning.